Okay, this is the evaluation for the continuous assessment, which is quizzes. Marks, either 10 marks or 15 marks we will conduct, and the weightage will be for 10. Okay, both the quizzes, either 10 or 15 marks we will conduct, and then it will be converted to 10 marks. And the first quiz, I have mentioned it to be as tutorial. So that is by using this bracket tool. So either we will have to will give, or can I give you the partial code and ask you to fill up? Yeah.
Ma'am, your voice is breaking. I don't know.
Yes, Vikas.
Your voice is breaking, ma'am. I think it's
On campus. Let me change my network.
Continue, ma'am. Continue, ma'am. Just sometimes in between it's breaking.
If it is breaking, you just let me know. I'll pause for a time and then we'll start. Tutorial part, what we have planned is we will have either one program given and ask you to implement completely and upload it. We may give you the partial code and ask you to fill up the remaining part. So quiz one we will have it just before the someday before midterm exam. That too when there is no placement any particular day. On any day, if you are having no placements, on that day we will have it quiz one as well as quiz two. And quiz two we will have it after midterm exams. I think midterm exams have been scheduled during the last week of August, right? So we can plan for quiz one and the second week or third week of August. Okay. So we'll see when there is no placements. So this is for continuous assessment. The remaining two, midterm as well as the ENSEM, you will be having midterm which will be taken for 30 marks, online exam which will be conducted for 30 marks, 1 hour exam, it will be taken for 10 marks, and the Viva will be conducted for 20 marks. End semester exam, similarly, we will have it online exam 50 marks and it will be converted to 20. Viva which will be conducted for 30 and it will be taken for 30 itself. So this is the finalized pattern, evaluation pattern. Okay. So let's move on with the topic which we have been discussing. All these things we have discussed. Code block, Fibonacci, its nature. Yeah. Yeah. We were discussing with respect to order of growth. Covered till here, Fibonacci series we have discussed in an iterative way also. In last class during lab also we have done this. Okay. Order of growth. So what do you mean by this order of growth? Order of growth is nothing but which we will be discussing with respect to what is the how do we how we can measure how much that is like when we are saying any program, how we can measure the computation. So the way how we measure the computation is what we call it to be as the order of growth. So when we say computation, it can be with respect to how many number of steps process type of process your program is going to generate. So as we have discussed, we have seen with respect to whatever program you have writing, that is whatever procedures you have written, we can either get linear iterative process or linear recursive process, or it could be tree recursive process, right? So either of these three processes will be the one only which we can generate, or it could be a single step execution. So only these four things are the only possibility. So when we based on what type of process you are having, how your program is execute, that is how many based on this process and based on the input what you are giving, what is the amount of what is the amount of completion of growth. So that measure how we can do it in analysis of algorithm. You have studied like big O notation, theta notation, omega notation, all these things, right? So as a general terms, we will be usually taking in terms of theta notation. So here also we are mentioning the order of growth in terms of theta notation. So I have just given the definition for the theta notation at the last paragraph. So hope all of you remember that we have two constant values k1 and k2 which are independent of n. So what is this n? N is nothing but the input what you have given. What based on the of your input, the problem what you have mentioned, that is what is considered to be as your n. So if you are saying k1, so since we are using this theta notation, so it should be k1 f of n less than or equal to r of n less than or equal to k2 f of n. So you know how this definition has come and all these things you have discussed already in analysis of algorithm, right? Okay, so let us now see with respect to each process, what is the growth, how is the order of growth, how we can represent. So hope all of you remember the factorial procedure which we have discussed. So in the factorial procedure, whatever we have written, the procedure name, we had single argument and we had a condition. Based on that condition, you will decide where till your n has reached 1, it will return the value, it will return 1. Otherwise, it keeps calling the same procedure by reducing the n value. Right. So that is what is the first procedure what we have discussed defined for the factorial. So how we can represent, if you remember the here in this itself we have, if you remember the process how we had, this is how the process we had. So order of growth in terms of steps, if you take out how many steps we would be having it, say if your n is 6, we have almost 12 steps, so which is like 2 into 6 kind of thing. So multiply 2 with the n value. So if it is 5 means you will be somewhat having till 10. By the 10th step you would be getting the result. So 2 into 5, something like that. So within those many steps, you will be getting the, or see till here. Till here is the function calls which we are doing, right? Till here. Or once you finish with all the function calls, then you start evaluating. From 6th step onwards, all the things are nothing but evaluation part. So it is like the order of growth in terms of the number of steps will be nothing but it will be theta of n itself. So if it is 6, so it will be 2 into 6 means the 2 is considered to be as constant. So the higher priority will be given for your input n. So it will be considered to be as theta of n itself. What about the space part? How much space it is going to occupy? So if you see each step, you see you are having multiplication followed by the value, then you are calling the function. Similarly, in the second step, if you see, we have to remember 6 and 5, multiplication of 6, multiplication of 5, and then you are calling the function. So like that, if you see till here, you have to memorize multiplication of 6, multiplication of 5, multiplication of 4, like this till 2. Then only you are calling your factorial function. So that means each time you are calling the function, we have to remember these many contents along with your n value. So that means it is nothing but that is what we can say it to be as the memory. So the space requirement. So here also if you see it is almost same as the n value. If it is linear process, it is going to be theta of n. Okay, so if you have written the procedure in this way, which generates linear recursive process, is going to have the order of growth to be theta of n in terms of space as well as time. Similarly, if you see the iterative process, so iterative process. So if you have written the same factorial procedure with respect to this linear iterative fashion process, so how it is going to have? So here also factorial of 6 we have got. So yeah, that is a factorial by initializing the 1 and the counter value, the 6 remains same. So that kept on calling till your the counter has crossed the value. Once the counter has crossed the value, you were returning the multiplied value, the final result. So now, if you for this procedure, if you have to identify, identify the order of growth, how it is going to have. So if you see factorial of 6, we are calling. After that, 4, 5, 6, 7. So almost one step more than that, or 2 steps more than that. By the time you will be getting the final result. Once you get, so what will be the now order of growth in terms of computation? In terms of computation, it is like if you are we are having almost n plus 1 or n plus 2 steps by the time you will be receiving your final answer. So it can be considered to be as, since we are in higher importance is based on the input value, that too it is for 1, we can say that it is theta of n. So order of growth for this type of process, it is going to be theta of n. Coming to the space part, order of growth in terms of space. So when each time you are calling the procedure, here we had only single value to be remembered. Here we had 3 values to be remembered. So almost it is like till the end you are having 3 values to be remembered. So each time you are calling the procedure, 3 values we had to remember. Whereas in the previous one, in the linear recursive process, we had to remember one. Along with that, you had before you had some more contents like multiplication of previous value, that also you had to remember. So that was the reason why it was n. Now here you see, each time you are calling the procedure, you are having the same number of that is you have to remember only 3 values. Each time it is you kept on replacing these 3 values itself. Right. So it is like always each time you call, you have to call only 3. Memory space required is only 3. So that means what happens? It is like it's like a constant. So how do we represent the constant for the order of growth in the analysis of algorithm? So constant means which will be represented to be as theta of 1. So that is the reason why we kept saying here for the order of growth for factorial, when it is linear recursive, it is theta of n in terms of space as well as time. It is theta of n when your factorial procedure is defined, which was having iterative process, which generates iterative process. The number of steps required is theta of n. The space requirement is theta of 1. We have considered because each time you are calling, you have to remember only three contents. Because of that reason, it is considered to be as theta of 1. So almost it will be like you are writing a procedure which generates a recursive process. Almost you can see the same pattern. It will be theta of n with both space as well as the time requirement. Similarly, if it is linear recursive, if you have written a procedure in the linear recursive, linear iterative process, which generates linear iterative process, almost it will be the number of times you are calling the procedure, and the contents which you have to memorize also will be constant. So the space requirement will be constant, whereas the process will be the number of steps will be theta of n. So we'll see the same order of this exponential procedure. What is this exponentiation? Exponentiation means which is nothing but finding some b power n. So you are having some base power n. So how usually we find it? We find it whenever we say b power n, which will be nothing but b multiplied by b n minus 1. So how long you will go till your n reaches 0. So once your n reaches 0, we can return the value to be as 1. Otherwise, we keep multiplying the same base with n minus 1. So can you define the procedure for this? Students, are you defining? Just define the procedure for this. Because you have to get used to with this brackets, writing the definitions and all. So if you are given how many inputs we will be having, we will have only two inputs. One will be the base value and the n value. So since we are defining the procedure, we can write it to be as define, open bracket, define, one more open bracket where we give the name of the procedure. So the name of the procedure given is exp space b, which is our base, space n value. So what to the power of how much it is you are going to find. So 2 to the power of 7 or 8 to the power of 9. So which base and what is the power of it? So till how long it has to go? Till your n reaches 0. So we can have only one condition if n reaches 0 or it could be some other number. So we have only two cases here. So I can go using with if statement. So if with this if syntax I can easily finish it. So if I'm just mentioning n is equals to 0, you have to follow the syntax. So all the operators comes at the beginning. So equality, we use equal to operator, equal to n0. If this is the case, then we can directly return the value 1. Otherwise, we are applying multiplication operator onto the base value, which is b, and again we have to do b power n minus 1. So that means again I have to call the same procedure. Recursively I have to call the procedure. So exp base is b, and each time I am calling it will be reduced. N value will be reduced by 1 time. So n minus, that is minus n by 1. Close all the parentheses, whichever parentheses we have opened. All the parentheses should be closed. If statement should be closed, define should be closed. So this is how we write the procedure. So by seeing this procedure, what type of process it is going to generate?
Linear recursive.
It is linear recursive process which is going to be generated. So what will be the order of growth for this? We have taken up the example with respect to 2 to the power of 3. So each time till my 3 reaches, each time I am calling the procedure, I am reducing the n value, and once it reaches to 0, this is the pattern which we are going to get. So what is the order of growth for this? In terms of steps?
Theta of n.
Theta of n, because how many because it is with respect to 2 to the power of 3 each time we are reducing it by 1. So almost the n whatever we are saying, it is nothing but our power value theta of n. In Someone can respond? How do we calculate the space one? If you see the pattern here, we are having multiplication operator with some value, the
Order of n, no, ma'am.
base value. Again, multiplication of maximum one I have taken. So when we are saying each time we are calling the procedure, we have an operator as well as we have an operator as well as the value which we had to remember. So, so the space, the complexity will be nothing but here also it will be theta of n itself. So maximum if you see here, which is the expanded one, three times we have to remember the operator as well as the base value along with the procedure call contents. So here also it will be considered to be as theta of n itself. So this way of writing your procedure, that is remembering the operator followed by some content and then followed by your procedure call, something like this type of pattern or this way of writing your procedure, we can call it to be as differing operation. Okay. So the same thing, instead of defining it in this way, we can even define it in another way. That is the procedure how we have, instead of defining the procedure the way how we have defined it, we instead of it we can even write it in this way, like define exponential procedure where we are calling the sub exponential procedure where we are passing the base value as well as the counter has been set and the product one. So if your counter reaches 0, we are returning the product. Otherwise, we are calling the sub-exponential procedure where base will remain same. Each time I am reducing my counter value because my counter is nothing but the n value. I am reducing my counter value and I am maintaining the product. So product into B. I have closed all the procedure. Before I close this exponential procedure, I have to call the sub-exponential procedure. So I'm calling the sub-exponential procedure where my base value will be nothing but the same B value itself. Counter will be nothing but N. Product will be, I'm initializing the product value to be as 1. So inside that procedure, first time whenever I'm using this product, it will be taken it to be as 1 itself. So if you have defined the procedure in this way, what happens? We can say that even though the procedure is in the recursive fashion, that is here we don't have any looping concept. If we have to get the looping concept, we have to keep calling the procedure again and again. We have to have the recursive procedure itself. But the pattern, the process, what you are going to generate only will be differing. So if the procedure is defined in this way, the process what you are going to generate is linear iterative process. So it is for the same example exponential of 2 to the power of 3. So we are calling the sub-exponential procedure where 2, 3 and 1 will be passed. Next, we are just checking whether 3 is equals to 0. No. So we will be calling once again the sub-exponential procedure where base will remain same. Counter value will be reduced. Product will be nothing but 1 into 2. 2 will be maintained. So like this, it will go on till your counter reaches to 0. Once your counter reaches to 0, we are just returning the product value which is 8. What is the order of growth for this one in terms of time? Here also base value to the power of n. It will be theta of n itself. What about the space part? It will be considered to be as theta of 1. Yeah, because it is each time you are calling the procedure, we have to just remember the values whatever we are passing it. And each time it is 3. Maximum it is 3. Before first time it was 2 and then it was rest all but 3. That's a constant value. So we can say that it is theta of 1. Okay. One small thing. In this procedure, you can even make the b to be as a free variable. That lexical concept. You don't have to pass this b. You don't have to pass this b here. Already b is here, base value, and you have defined one procedure inside. That is, you have made it to be as a block structure. So you don't have to have one argument could be reduced, but still you can use this b here because you have defined sub-exponential procedure inside the exponential procedure. And b is already an argument inside this, so which can be accessed inside your exponential procedure. And sub-exponential is inside your exponential procedure, so you can reduce one argument for your sub-exponential procedure and you can make b as a free variable for your sub-exponential procedure. For sub-exponential procedure, product and counter will be the bounded variables. Similarly, for exponential procedure, b and n will be the bounded variable. All others like equal to operator, minus, multiplication, b, all these will become your free variable. Free in the sense which are already globally available. Okay, I mean which is already defined outside this procedure. That is what is meant to be as free. Just thought of highlighting that one more point. Okay, coming to the, there is one more way of defining the same exponential procedure. Instead of defining the exponential procedure linearly, like till your n reaches to 0, you kept on decrementing it by 1. Instead of it, we can even verify it do it with respect to your n value is an even number or an odd number. Say for example, if you are calculating b bar 8, so b bar 8 can be calculated if that is like we can multiply the value with respect to b power 4 into b power 4 could be done. How we can calculate b to the power of 4? B to the power of 4 could be calculated based on b to the power of 2 into b to the power of 2. How do you get b to the power of 2? Which will be nothing but b into b value. Right? So that is nothing but we can identify your n value is an even number or an odd number. Just you imagine if you have to calculate b to the power of 8 and both the ways which you have defined it, linear, recursive, both the procedures which you have defined, if it is going in that way, the number of steps which you are going to have, you can just imagine. Here, if you are doing it with respect to this logic, identifying whether it is even number or odd number, it is within these 3 steps, you could get your final answer. B to the power of 8 could be calculated with respect to b to the power of 4. Once you get b to the power of 4, how do you get b to the power of 4? By calculating b to the power of 2. How b to the power of 2? Just by multiplying b into b. So how we can do it? If your n is even number, just find the square of b n by 2 whole square. That is, just calculate the square for b to the power of n by 2. If your n is odd number, what we have to do? We have to make it to be as an even number. How we can make it to be as an even number? Just you can multiply one time you can multiply the base value multiplied by b to the power of n minus 1. When you say n minus 1, since your n was an odd number, this will become even number. So once it is an even number, you can make use of this logic again. You don't have to go linearly. So can you just define this procedure for this logic? have already, I just have defined here even procedure, but if you are using the racket tool, in racket tool there is already built-in procedure called even question mark. You can directly call it, which will return the results in terms of true or false. And here the true or false will be represented as hash for yes, hash for false. Hope all have seen during the so just defined it for you to say about the reminder part. So define even just for identifying whatever value you are passing, whether it is an even number or not. Since we have to get the reminder value, we are using this reminder procedure. Reminder of x with 2. And if I just wanted true or false, so I have used the equality with the 0 because it is even one, even procedure. In racket tool, this even procedure is a built-in one. You can directly use it. So when we are defining the exponential procedure, here also we have two arguments, base and the n. How many conditions now we have? We have to check whether your n is an even. Similarly, if we have to check whether n is an odd. Is the space sufficient? No. Where at what point of time it has to stop? When your n reaches to 0. So we have three cases. So since we have three cases, we can syntactically it is better to go with can't, or if you are writing if, then you have to make sure if again in else part again if comes. So it will be like a nested if else if ladder. Then it will be so many brackets you have to take care. So better you can go with can't. So first one what I have given is whether my n value is 0. If it is equals to 0, return 1. If it is not equals to 0 means then it is a bigger value. If it is a bigger value means it could be either even number or odd number. So first I am checking whether it is even number. If it is even number, already I have defined square procedure. Long time back we have already defined the square. So I am directly using it. Square square of b to the power of n by 2, right? Again I have to call the procedure. So once again I am calling this exp procedure where my base will remain same. What about my n value? It has to be reduced by half. So n by 2. So division divided by n by 2. So this is what we have to keep doing when my n value is even. If my n is odd, what we have to do? I just have to apply this part. So where I am applying multiplication of b and b to the power of n by n minus 1. So that means again I have to call the same procedure. So exp is getting called again. Same procedure is getting called where base value will remain same and n is being reduced by 1 so that it becomes the even number. So that I can apply from next step onward, I can apply for this. I can go for this step. And I'm closing the condition part. I'm closing the define part. So always remember this else we will be using it only for when we are using this kind. Okay. So now just let me know what will be the order of growth in terms of time for this part. We have seen the order of growth with respect to b to the power of 8. So b to the power of 8 means how many steps we had? We had only b to the power of 8 has been done. B to the power of 4 into 4. B to the power of 4 means 2 into 2. B to the power of 2 means which will be square of b to the power of n by 2, which is 1 and 1. After that, when your n is an odd number, when I say n is an odd number, we will be having b multiplied by b power 0. So when it is b power 0, it will just return the value 1, right? So only mainly I can say this to be as hardly 4 steps. Just imagine if you are calculating b to the power of 12. Your n is 12 months. Next step will be b to the power of 6 into 6. Next step will be b to the power of 3 into 3. After that it will be, since it is odd number, b into b to the power of 2. So like that, when you do, is it same as the previous one, previous two process? What type of process this procedure will generate?
Ma'am, it is recursive, but it is not linear. It is in log n.
Order of growth will be log n, but here, what type of process it is going to generate? Is it linear recursive process, linear iterative process? Which one it will be?
We can't say it to be recursive.
We can't say it to be as recursive, linear recursive, because only in one step, when it is odd, only one step you will be getting it. Rest all will be linear iterative. So majority it is linear iterative. So you can say that it is linear iterative process. It is going to generate linear iterative process. Coming to the order of growth, it is only half of the times we are required. So we can say that it is logarithmic. So log n. So same as your space also, if you see, the space requirement also, how many times you are calling this even or odd, based on your n is even or odd, those many times only you are calling the procedure, or only one time you will be having this multiplication of base value to be remembered. So that is also same as your log of n. Okay, so here the order of growth will be for time as well as for space. It is theta of log n. Okay. So a few more examples are there with respect to for taking care of this how the order of growth. One is with prime number and the other one is the GCD procedure. So these two cases we'll see it in the next class. It's almost time. So I'll stop with this. If I start also, I will not be able to finish.